Let's build your first AI model that's gonna predict who's gonna win the Formula 1 this year in Melbourne, Australia. So we're going to build a really simple model so you definitely can repeat it. And this model is gonna predict the Formula 1 winner. The Formula 1 that's gonna take place in Melbourne, Australia in 2026, so really soon. So let's try to build it. First, we import our libraries. We import pandas. It's a library for working with tables of data. It's like Excel but in Python. We import NumPy. It's a math library. We use it for arrays and random numbers. We use scikit-learn library, and we import random forest classifier from it. This is actually our model, our algorithm we're going to use to predict race winners. Then we import train test split. It's the function that splits data into training and test sets. We import our metrics, classification report, ROC score to understand how good our model works. And then we use random seed 42, which makes result reproducible. So every time we run the model, we get the exact same output. Then we're gonna use real historical data. It's from the FORMULA-1 API that gives us access to all the historical data of Formula 1. And I already took it from there and left it in F1 data CSV file, and you're also gonna have it in your GitHub. Inside the GitHub, I'm gonna leave you. So all the data is gonna be from there. Here we have our features. These features we also took from our real data from the FAST1 API. And this 7 inputs the model uses to learn. Our target is 1, if the racer won this race or not. And that's what we are trying to predict. Then in our data, as soon as it's a real data, we have some missing columns there, missing rows there. So this line, df dropna, removes any rows where one of the 7 features is missing, because a row with missing data would crash the model. Then we split the table into inputs, X of features, and our label, Y, one or not, our target. Then we split the data to training and test sets, because we don't want to train our model on test set. We want to check if it works right. So we don't want this data, like data leakage. We don't want this data to be seen by model before we're gonna test it. And we should just split data 80% for training the model and 20% for testing it. This stratify equals Y ensures that both splits have the same ratio of wins and non-wins. And then we initialize and configure our model. This is going to be random forest classifier. And estimators means that we built 200 decision trees. The max depth of every tree can be at most 8 levels. Each tree can be at most 8 levels deep. Then we have minimal samples leaf equal 5. Each leaf needs at least 5 examples. So this just to prevent overfitting. Then we compensate the imbalance that only 5% of rows are wins. And random state gives us reproducibility. 42 can be any number we want. And number jobs is -1. So we use all CPU cores to train faster. Then we actually train our model fit. You can see we use only train data, xtrain, ytrain. And then we make predictions on the test set. Y predicted equals model.predict on x test data. It's output 0 or 1 for each row. Then we get win probability from 0, 0 to 1, 0 instead of just 0, 1. And this part takes the probability of class 1, which is win. Then we evaluate our model and see the metrics. We can see our CRC score. That it measures how well the model separates winners from non-winners. And if we have something like 0 and 5, it's like random. And if you have 1, it's perfect. And you're gonna see that we have almost 1 score here. So it's very good. Then we print precision, recall, and F1 score for both classes. This is inside the classification report. Then we're gonna load our Australian grid we built with also with this fast F1 data. And I already saved it to CSV file. You will have it also on the GitHub. Then we extract the same 7 features from the 226 grid. So because the model only accepts inputs it was trained on, so we need the same features. And with this win probability, we ask the model, given these race conditions, what the probability of each driver wins. Important here, we normalize probabilities, so they all add up to 100%, because without this they might sum like to, 87% or 112%, which looks wrong. And we sort all 22 drivers from highest to lowest win probability. Then we look through the top 5 drivers and print a visual bar chart. Head 5 means that only top 5 we're gonna print. If you want to print more of them, you can delete head 5 or use any number you want. And you will see now how it looks like. So here we have a pretty good OCRC score, as I told you, like almost 1. Pretty good accuracy. And what about prediction? Our model predicted that Lando Norris will win, but Max Verstappen, Oscar Piastri, George Russell, and Charles Leclerc also have pretty good chances. So let's see. Very soon we're gonna know if our model was right or not. You can take the link to GitHub and try to run this model by yourself in description. And if you want to learn how to build your own models, join our ML platform. You will also have a link in description. There you will learn by practicing, by building your own models, and it's going to be really interesting.